Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our modern C++ series. In this lesson, we're going to continue talking about the standard template library. Now, if you've been watching this series, last time we talked about in the STL, the standard template library, the map. And this time we're going to be talking about multimap. So multimap is also an associative data structure, but this time allowing us to have multiple identical keys. Now we'll talk a little bit about how that's different, but let's just go ahead and look at our example before we go ahead and dive into CPP reference and learn about this data structure. So previously, again, if you've been watching this series, if you have subscribed, then you saw when we did set and the unordered set, or even multi-set, they were essentially drop-in replacements. So let's go ahead and try the same thing here in our STL. And what I'm going to go ahead and do is do a little bit of a recap of our example, just in case you didn't see that map example that we did last time, and just to get you a little bit oriented. So again, we're going to include the map header here. I created a custom data structure here in Edge just to show you something that's less trivial. We gave a constructor and then a stream operator so that we could easily print out the elements that exist in our map. And then it's also useful if you're learning some of these data structures and again working with something that's not trivial. So for example, an Edge which has two fields, to understand how to compare them. So we wrote a little comparator function here, which is a functor. That is a object that can be called when we override the operator with the parentheses here. So that way we can actually compare and determine why one edge is less than another for whatever metric you want to make up here. In this case, just the vertices here. So anyways, we had a map here. We created a map where our key was a string, the value was an edge, and then we created some different edges here. Now, noting again that with the standard map data structure, that in edge 1 will get replaced if it's already in our data structure here. So this edge 0, 0 would get replaced with edge 1, 1, for instance. And then we can actually look at or access in our map using the .at operator, as well as the brackets if we wanted. So those were just some of the things that we could do here. And then again, we looked at inserting pairs because again, these are key value pairs. We looked at structured bindings, which is a neat C++ feature where we can actually retrieve our pair here and just sort of easily access things in the pair with our first and our second item here. So again, that's how we were doing this with first, for instance. And then I show you some different ways that you could iterate through your map here using classic iteration here by creating an iterator, again with a little helpful thing here, string edge iterator, which if I go ahead and scroll up here a little bit, we created this string edge as an actual type using the using keyword. So a lot of things that we've revisited in this series. That's again why I want to review this before giving you a new data structure. And of course we have range-based loops, which are going to go to use those iterators, and we can do things in our data structure like check if it contains a particular key here and then return the value if we need. Or in this case, we can actually erase a specific value here. Okay, so that's the idea. That's some neat things that we can do. And again, using iteration with structured bindings is pretty neat here. And then merging or working with various other operations is something we can do if we want. So now let's go ahead and do the experiment and see if we can just use multimap as a drop-in replacement. So without showing you this data structure, let's just go ahead and do multimap here. And let's go ahead and try to compile this using C++20. Again, multimap's been around for a little while, so we don't need that new of a compiler. But let's go ahead and try to run this. And let's see what happens if I hit enter, and wow, a bunch of errors here. Okay, so immediately we can start getting some errors like things like no match for operator with the brackets or .at. So it seems we need to dive into this a little bit more here to understand exactly what's going on. So let's go ahead and dive onto CPP reference here and look at the multimap data structure. Now again, you can see that this is something that's been around for quite some time. If I scroll all the way to the bottom, you can see this has been around since at least C++ 98 here, before some additions were made. And let's go ahead and just try to understand this data structure a little bit. So again, it's an associative container. That means we have key and value pairs here. So here's the key, here's the type. And if we need to, we can write a compare operation again to sort our actual elements in this data structure. So because it's a sorted data structure, that usually means, and again, we're sorting by the key here, that we're going to be using some sort of tree structure to get a logarithmic lookup for our complexity. Let's go ahead and sometimes if we just search for the word logarithmic, and here we find it in the description here. We can find that, again, search, insertion, and removal are logarithmic. If you search multimap GCC source, and I like to use GitHub here just to look, you can usually find here, if you look at the top of the description here, that there's some tree data structure here. And again, it's pretty similar as mentioned here. It says it works basically the same way as map for our multi-map. Again, the distinction being that we can have multiple elements that are the same. Okay, so that's the idea here. Let me go ahead back to multi-map on our help page. And well, let's go ahead and see some of these different operations, because again, remember, we got an error here, you know, for our member functions that we were actually accessing here. And again, let's actually open up map here just so you can distinguish between the two. So map here, I have some various element access functions here, at and the operator here for accessing. But I don't have those functions here. Okay, so I can do similar things like perhaps check if we contain something or find an element, but I don't have the actual ability to just access something, because there could be unique entries, so I don't know exactly which one that I want to access. So again, with the multi-map, let's just go ahead and summarize here, and then we'll dive into some code here. So this is multi-map. And again, it's an associative data structure. It is ordered, and it is a tree, probably a red-black tree in most implementations. So again, that usually means logarithmic operations. So usually log base 2 of n type of operations for insertion, search, and deletion. Okay, so that's the basic idea. And then the difference here, so difference between map is we can have duplicates. Okay. And again, that's sort of like multi-set versus set, that same sort of distinguishment. But again, it's going to change some of our operations that we can do here. So with that said, with multi-map, let's go ahead and look at some of these operations and how to use it, and namely just how to insert things and how to find things here. Okay, so let's go ahead and do that. I'll leave our help page here. Let's go ahead and reorient ourselves. And I'm going to go ahead and just clean up this example a little bit here. Let's use something a little bit easier here. And again, you can look at the previous lesson if you want to look at, you know, how to overload the stream operator here, do the comparison function. Let's just really strip this example down here to something relatively simple here, just so we can get something working here. Okay. Let's just work with a string and a value here. Okay. Like an integer here. And again, if we go ahead and look here, map is contained in, or multi-map is contained in map, so we don't have to worry about that. And you might ask yourself too sometimes, when should I use multi-map versus map? Well, again, think about if unique entries are going to be allowed. So a common example might be if you're implementing Google Calendar or something and you want some dates, for example. Let's put today's date here, 5/1/23, and I want to store a date or something like this. Well, I might have multiple sort of entries here in my actual structure here. So that's an example where it might make sense. Or if you have keys, again, that are going to be identical, things like Mike and Mike, you know, such a common name. So that could be something that you look at as well. For instance, again, we're going to have multiple entries. Sometimes you'll see these types of things in tools, for instance. So let's go ahead and open up a 3D tool. And often you'll have, because I do some, 3D work in game engines or modeling, you might have something like a scene collection that's naming things. And this would be an instance where, let's try to duplicate this cube here and maybe, I don't know, transform it or something, just so you can see that there's two different items here. But you'll notice here that these ones are uniquely identified. So, there is some different structure here, cube versus cube 001 in the key. So that would be a candidate for probably just using a map here. Okay, so that's just something to keep in mind, whether you need some uniquely identifiable entity or if you can have duplicates for the actual key here. Okay, so anyways, just a tiny example there for you might use map. Now, the other important thing to keep in mind with multi-map here, and I'll just put it here, it's ordered, and I would just call this a stable sort of ordering. So that means if I do insert Mike here, and I'll just put a little bit a 1 next to it here, that means that this first entry of Mike into my map is going to be the first thing, and it'll be preserved in the first position, and this will be in the second position. Okay, same with our dates. If I just keep adding them, the order that I add them, if there is a duplicate key, will be preserved. Okay, so we call that a sort of stable data structure in that manner. So anyways, with those things in mind, let's go ahead and work with multi-map. And I'm just going to rename this to my multi-map here, and let's get our documentation up so we can see what we're doing. So how do I actually add things here if I don't have the operator? So again, I don't have this operator here where I can just add things with the access or some other means. So instead, what I have here is insert. Okay, so let's go ahead and look at insert. And again, we could do things a couple different ways here. We could just insert a pair. We could insert at a specific position here if we have some iterator here. So let's go ahead and look at some of the examples here and see what we've got here. Where we can insert our sort of value type. That's kind of interesting. I'm going to do it just with this sort of simple, or rather the simplest way to do this with a pair here, which we've seen. So let's just do insert. Let's do a pair. And in our pair, we have a string. I'm going to use my name as an example here and a value, 100 for 100 points or whatever. And then let's just go ahead and insert that a few times, compile it, and see that this works just fine here. Okay, so now let's just go ahead and look at the iteration. I'll use a range-based for loop here. And let's just retrieve our actual pair here. Let's just do it by accessing the element here, and we're going to search through my multi-map, and then let's just go ahead and output the element and the first item here. Okay, let's go ahead and do first, and I'll put some spacing in here, and element second, so we can see the actual key here, and an end line. Maybe a comma just to separate things out here, make our output a little bit neater. Okay, so let's go ahead and give that a compile here. Oops, it looks like I gave a wrong arrow operator here because this is actually giving us the element that we need by reference. I'm not using the iterator here, so let's just do first and second. Go ahead and compile this, and just to make life a little bit easier, let me make this window a little bit bigger. And when I compile it, we're also going to run it, so we can see Mike and then the different entries here. Now, let's just go ahead to make things a little bit more interesting. Let's change these values just so we can see them uniquely. And I want to just show you at this point that, again, they are in order as I'm iterating through this particular data structure. Something also worth showing if we're going to just, start our data structure in this manner is we can use initializer lists here and just create a pair. Let's go ahead and do Mike and I don't know, 2 or something here. And we could have a bunch of these. Let's go ahead and put a comma and just create another entry here. Again, I'm doing them all unique sort of on purpose, just so that we can see that, again, the multi-map allows us to insert all of these elements here, regardless if they are unique or not. Okay, so let's go ahead and run it. And we can see that we are getting Mike with the 2, the 7, using this initializer list, and I'm using the curly braces here to insert a pair. Okay, so now you get the point here. Now let's go ahead and see if some of these other functions that we've used. Let's go ahead and see erase, for instance, just to see how this works. So erase. Now, we've got a few different ways that we could do this. It says iterator at our position here. Okay, so we're going to remove the element at some position. And we want to go ahead and see, does this erase everything here? Okay. And let's go ahead and just run it once and go ahead and see here what happens. So let's go ahead and do my multimap erase mic. I'll go ahead and run it. And then when we iterate through, let's see what happens. And in this instance, well, it gets rid of all of our entries here that match mic here. So let's go ahead and just take a look at this here. And if we look at entry number 4 here, because we just provided a key for whatever our type is, it says removes the element if one exists with the key equivalent to, well, whatever our key was. So in that manner here, we are getting rid of our elements. And oh, I should mention that we have a, because it's saying 0 or 1, I noticed a mistake here that I'm a map here. So let me actually go to multi-map here, make sure I'm clicking on the right thing here. My fault there. But just to show you the behavior here, erase, I think it'll say more clearly here that it's removing all the elements. So number 4 here. Perfect. Glad I actually showed that, because I don't think I showed that in the last video here. That we have the key here. It removes all the elements with the key equivalent. And let's see, there is a actual return. So the size here, telling us how many elements were actually removed here. Okay, so that's kind of nice here that we get that here. Now, if we do want to remove a specific element here, that gets us to thinking about how find works. So let me close out map so I don't make any mistakes here. So find a specific element with the matching key here. And the question is, will this return us one of the elements, all of them? And let's sort of mix that behavior to see how it works with erase and how we might want this to work here. So just reading through the description here, it says find an element with a key equivalent to the key. If there are several elements with the key in the container, any one of them may be returned. Okay, so this could be implementation dependent. This could be something that if it matters that you're eliminating the middle element for some reason, you would want to actually pay attention to this. So let's just go ahead and see how it works here. What I'm going to go ahead and do here is do my multi-map, and we're going to find some key mic. And I'm just going to use auto here. Well, actually, let me do it with auto just to show you, and then I'll write the actual type out, because again, it's useful to see all the types. And this time, again, for my erase, and let's go ahead and document this. So erase will erase all matching keys if a key is provided. If a key is provided. And let me make this a little bit bigger here so we can see. So that's what we'll comment out here. And in this particular example, we can erase a specific element that is found. So let's do my multimap dot erase and our iterator's position here. So now if I run it, it looks like it is indeed getting rid of the first item that is at this specific iterator position here. Okay, now let's go ahead and see if I can type out the iterator correctly here. So this is a standard multi-map, and again, I'm just going to look at the signature up here. Multi-map of string int and iterator f. Okay, equals my multimap dot find mic, and let's just go ahead and comment out here, just to show you that this is the equivalent code. Okay, so again, usually this is a case where I like using auto when I'm working with iterators and some of these longer types, or as I showed you last time, we could actually do a using string int multimap equals standard multimap string int, and that way you have the whole type here. Okay, if you don't like typing out these different things here. So let me again just show you the third way that this is equivalent. Part of this is a little bit of a review of our series, but I like to do a little bit of review just so we see these different things multiple times. So again, let's just do this one more time using our string int multimap iterator f equals my multimap find mic here. Okay, so again, it's the equivalent thing here. We've just got that alias for our type with the using keyword, and it's within the scope of main. Okay, so now that we've sort of focused on that and some of the different operations that we might want to look for example, if we are erasing something, let's go ahead and just look at a few more of these operations here, like count, returning the number of elements. So let's go ahead and before we erase something, let's go ahead and print out the count in our multimap. Let's do count, and it's looking for a specific number of keys. Let's look at the first, the whole help page here. So number of elements with a key that compares equivalent to the argument here. So we can actually just check that out here. All right, so let's go ahead and we've been using Mike here. And let's go ahead and close this parentheses here. So I'm going to call it before and after our erase, and we should see that number change here from 6 instances of Mike down to 5. Okay, so that's pretty neat here. Count, again, useful tool that has been available in Multimap for some time. And we also have contains here just to check true or false if that key is available. And then you can decide with your algorithm if you want to remove the first Mike or the last one or whatever. So now that we've looked at that a little bit here, let's kind of look at an interesting problem where we might say, well, what if I actually want to do something with all of the keys? For instance, I want to actually update the values, okay, that I actually find here, or just print them out, something that we might want to do in a database, right? What are my actual meetings, like we looked at in this example, if I want to print out all of the dates of my meetings or all the people named Mike in my database? So what I'm actually going to do for this here is, well, our options are to either iterate through the entire collection here, but we've also got these interesting lower bound and upper bound functions, and even this equal range one that's kind of interesting. So let's kind of look at this here. Lower bound returns an iterator the first element not less than the given key. Okay, so if it's not less than the key, however it's sorted, it must be equal to that key. Okay, and then we have upper bound, which returns an iterator to the first element greater than the given key. Okay, so that's also kind of interesting. So let's kind of take a look at this here, this upper bound and lower bound functions here. And let's go ahead and just make our multimap just a little bit more interesting by inserting some other entries. And I'm going to insert them somewhere here, just in the middle. And let's go ahead and do Tomoki, something like that here. Okay, so let me go ahead and just print this out just so you can see here. And let's make it on the list here. This is our actual multi-map here, and you can see that we've got some interleaving here of our different entries, and they are coming in sorted order, right? So we know how to sort strings, so that's why you're seeing Mike and then Nick and then Tomoki, so it's doing the alphabetical sort by the first character here. Okay, so that's great what we have there. But again, let's try to find some of these entries. Let's print out, instead of everything, just all of the Mikes here. So what I'm going to actually do for this is, and I'm going to need my helper here, is from this lower bound, again, it's going to take a key and give me an iterator to the first thing that is not less. So whatever is equal to Mike. I want to get all my Mikes here. So let's go ahead and, since this is our iterator, again, we could do this multiple ways. That's why I was showing you. I could do this. I'm just going to use auto. And let's go ahead and just call this the first entry, which equals my multimap. Lower underscore bound, and then the key that we're looking for, which is Mike. Okay, so I've got that under control so you can see the whole screen here. And let's go ahead and check out last entry. And let's go ahead and see if what the upper bound gives us here. Okay, so let's do upper bound. All right. And then now that we've got the first element that we're looking for on the last element, well, we can sort of write this for loop like we've been doing in many of our other lessons here. So we're going to say our first entry, which I've already got here, so I can just go ahead and put an empty semicolon here. I'll move these into the loop in a moment here, but I want to just show you them separately first. And then what I'm going to say is, well, our first entry is not equal to the last entry here. Then let's go ahead and move that iterator here, our first entry. Okay. And then let's go ahead and print out. And I'm just going to, let's just print out the key here. So that'll be the first entry. And now this is an iterator. So that means we actually have a pointer to something. So I need to dereference it. See if I can get that right on the first time. And let's go ahead and see what that does for us. I'd like to also just print out some empty spaces here just to show that this is a different experiment, so it's a little bit easier for you. Let's bump this up a bit on the screen. There we are. Okay, so let's go ahead and see if this works here. Go ahead and give that a recompile. And then now we can see that, you know, under our little experiment here, our first entry to our last entry, we get Mike. So here's our original multi-map. It still is unchanged here, so we've got it here. But I've got 1, 2, 3, 4, 5 entries, and then 1, 2, 3, 4, 5. And again, if we want to see that these are the equivalent ones, well, I can just do a little bit more with the output here and do our first entry. And again, this is a pair, so we want the second field. And let's put a comma there just to make it look nice. And then you can see the equivalent keys here, okay, or the values for each of these keys that are Mike here. So we've got our range here, and that's one way that we can actually get all of the events here. So again, if you're building a calendar app, a to-do list or something that has all the similar named events or whatever, if you just have multiple keys, this could be your tool. Now, we're being a little bit inefficient here, so before we wrap up, I just want to go ahead and show you something that we could do that's a little bit better here, because technically when we're finding this iterator, we are searching our whole multi-map here for the lower bound, and then we're searching again from start to finish on the upper bound. So that's it's still a O of n operation, we're just doing it twice. So we can get rid of that constant factor and do something that's a little bit more efficient here. So let's actually look at our standard library. So folks thought about this, and that is what this equal range is here. So it returns range of elements specifying a specific key. Let's go ahead and just take a look at this here. And what it's actually doing is, again, using that handy pair here, just like how we got the first entry in the last entry, but we're getting them in one sort of go. So you could imagine this sort of doing one pass, finding the first iterator, and then continuing until it finds the next entry, okay, if it exists. Okay, so we could go ahead and see that. Let's see if they use a structured binding or something here. We could try to get a little bit fancy with this. Equal range here, and they're looking for 2, so they find here. Okay, so they just find the range first, range second. That's okay, it's just the pair. But if you wanted to put these into separate entries, you could actually do this. So again, let's just document this. More efficient way of getting pair of iterators, or at least I believe it to be more efficient here. Let's go ahead and do auto. Let's do our start, end, or whatever you want to call this, my multi-map. And it essentially looks the same here, equal range. Okay, and then the actual key that we're looking for, Mike again, just to show that these are equivalent. And let's go ahead and do for the start, end, dot first here. While that's not equal to the start end dot second, then we'll go ahead and do the start end dot first, plus plus. And then I'm just going to borrow this code here again. We have our iterator here, and we'll go ahead and just to make this, actually let's make this a little bit cleaner here, kind of reflecting what they did in their example. Let's just say auto it equals start end dot first, and while we don't equal the second, let's put this on one line here so you can see what's going on here. Just a little bit cleaner syntax here. So the iterator, the first, the key, and the value. So again, remember this is a pair of iterators here. More efficient way of a pair of iterators. So start end is a pair of iterators representing the essentially the lower and upper bound, like we did in that previous experiment here. Okay, let's go ahead and put a new line here. Once again, to show you multi-map, let's go ahead and compile it, see if I made any errors. Oops, made one grave mistake here. For what I'm doing here, I didn't update my iterator here. because we eventually want to terminate. There we are. So you can see that we get the equivalent of our above here with this equal range. Again, it might be interesting to profile or something in a big collection to see how much faster it is, but ideally you shouldn't have to call those two separate operations. You should just be able to get that pair of operations if you have equal keys here. All right, folks, so with that said here, that's multimap. So again, showing you the different keys. If you want to go ahead and look at how to sort this, if you have a couple a different type or something, you can go ahead and look at the previous map video in the playlist and see how to set up the comparator. Again, if we look at the multimap data structure here, again, you'll see that it has the same type that we can, or template parameter rather, that we can overload if we want, as well as an allocator, which eventually we'll get to in this series. So anyways, just a quick recap on multimap to show you what's going on, what we learned here. Similar to map, it's in the map header, except for this time with multimap, we can have keys that are equivalent. So you'll see that here as we created our different pairs here. We can use iterators, just like we've been able to use a lot of the same functions. Count is actually more meaningful because it's going to give us 0, 1, 2, 3, whatever many different keys that we have here. When we erase, we can erase all the keys, or we can just use an iterator to erase one of those keys. So again, we're getting some practice with our iterators. And then again, if we want to actually return that full range of all of our keys, so versus just find, which is going to give us 1, which was fine when we just had a map, because again, there was only one unique element. But if we want that full range, we need a pair of iterators to give us the upper and the lower bound, and we found a more efficient way to do that with equal range here. All right, folks, hope you enjoyed that, again, monster lesson on the STL, but hopefully it gives you a good idea of how multi-map's working, and we're going to start putting some of these things together with algorithms and so on. There's kind of interesting things that you can do with find if and erase if and put predicates on some of these different things. So again, the standard template library, knowing it, working with it, getting some practice like you are in this series is hopefully going to be very beneficial to you later on. As always, folks, thanks for your time and attention, and I'll look forward to seeing you in the next one.